So hello and welcome to week number 15. This is the last week. In fact, we're going to finish up the material today. Last time we did chapter 6 on two-way tables, correct? Yes, correct. And then we started chapter 24 on the chi-square test. Did we finish the first chi-square test of independence? Did we finish it or did we only start it? Did we get to like a conclusion, reject, don't reject the null hypothesis scenario?
I think we did, but I don't remember.
I don't think so. You were teaching us how to do on the calculator.
Okay, so what was it was the home example, right? It was, okay, let me share my screen here. It was the people living at home versus not at home question. Right? I think that was the one.
Yeah, with their age and then.
Yeah. So so we had the following scenario. We had this table. And we had different ages, 19, 20, 21, and 22. And then we had various options where people live with their parents, another person's home, your own place, in a group quarters, or other. And here were the counts. Oh, yeah, wow, that's horrible. So 324, 378, 337, 318 for a total of 1357, 37, 47, 40, 38 for a total of 162, 116, 279, 372, 487 for a total of 1254, 58, 60, 49, 25 for a total of 192, and 5, 2, 3, and 9 for a total of 19. We also had the column totals of 540, 766, 801, and 877 for a grand total of 2,984 people in the survey. And we are doing a test, age and living situation are independent versus age and living situation are not independent. This is a continuation of chapter 24. In fact, we're basically restarting chapter 24 in a sense. So we're doing a hypothesis test. Are they independent or are they not independent? So we're going to have our calculator do the work for us. So second matrix, and we're going to edit our first matrix A. And what size matrix are we going to make here? What size matrix are we going to make? Anyone?
Four by five.
It's going to be a 5 by 4, 5 rows, 4 columns, a 5 by 4 matrix, 5 rows, 4 columns.
That was close.
And what numbers are we going to put in there? What
All
number?
the data, right?
All the data, all the data. So go ahead and do that, please. Put all your data in. How many degrees of freedom are there in this problem? Did I give you that formula yet? If I did, you could know the answer to this. If not, I'll provide it. But did I give you a formula for how many degrees of freedom there are?
Yes,
Yeah.
you did. It's
Uh,
rows -1, columns -1.
Okay,
Mo-
so what do we have here then in this problem? How many degrees of freedom are there?
12.
12. 4 times 3, 12. Now, is everyone who's doing it have their matrix complete of their data? Yes, no, maybe so. Everyone's matrix complete? Hold on, guys, 1 second, give me a second. Hold on.
Is this the same one as last time?
This is the same, this should be the same problem as last time, is it not?
Yes. I already have it on my calculator.
Oh, wonderful. Okay. So the first matrix, our first 5x4 matrix are the actual observations. Now, if the two variables were truly independent, then the way that you calculate, without going into the theory behind it, but the way that you calculate how many I expect to have in each cell, like for example, this one right here, the first cell. I take the number in the margin beneath it and the number in the margin across from it. And I multiply them together. So 540 times 1357. And then I divide by the overall number 2984. And when I do that, what do I get? Approximately? What do I get approximately, please?
245.57.
Yeah, so I'm just gonna round it to about 246, only because I'm gonna have my calculator do the work anyways, so it doesn't really matter what I write. But here's how we're gonna do it. Go back to second matrix and edit a second matrix. So you're gonna do a 5x4 matrix. This is gonna be matrix B, 5x4 matrix B. But I don't want you to put in 246 into the first entry. I want you to actually do the math. 1357 times 540 divided by 2984.
Oh, can you show how you do it on the calculator, the matrix?
Hit second matrix.
Second okay,
Okay, go to edit,
okay,
go down to B because we're putting in a second matrix now. The first matrix we already have, so now second matrix.
okay,
And it should look like this. Make it 5x4. And then the first entry, you're gonna do the math, 1357 times 540 divided by 2984.
okay, thank you.
What should we put in the second one?
1357 times 766 divided by 2984.
Yeah, so let's go through the entire thing. I'm gonna do it quickly here. And then you guys do it on your end. This should be done at least once in your life, just to say you did it. And then I'll put in my numbers so you can compare yours to mine. Okay, hopefully I didn't make any mistakes and your numbers are similar to mine. Okay. And tell me when you're done. This is the hard part. Once this is done, the rest of it's easy. Michelle, did you get the same thing that I did across the board? Great. Excellent. So I'll give you guys a couple seconds. I'm gonna write some stuff here. Okay, so the chi-squared is the sum of the observed minus expected squared over expected. And you add them all up together, observed minus expected squared over expected. And you get your chi-squared statistic. Now, I don't want to do that by hand. Even this matrix has 20 terms. And I certainly want to do that. So how are we going to do it on the calculator? So go to stat, go to tests. And which test do you think we're going to do?
Would it be D?
What's D?
It's like the chi-squared GOF of test.
Not the chi-squared GOF test. That'll come next. That's
Oh,
the other thing that we're doing today. Just a regular chi-squared test.
Okay.
So the chi-squared goodness of fit test, the GOF test, that will come soon. That'll be the second and last thing that we do. This is just the chi-squared tests. And what does it ask you to input before you can calculate anything? It asks for two things. What are those two things?
Observed and expected.
Observed and expected, and it should be left A and B. That's matrix A and matrix B. Because in theory, you could put any matrix you want, but we have the observed as matrix A and the expected as matrix B. So when we calculate, what do we get as our chi-squared? Approximately what?
193.55.
193.55. And what's the p-value?
6.98.
Try again.
It's point and like 35 zeros and then it's like
Oh, that's right, sorry.
Yeah, the p-value is 0. It's essentially 0. And because the p-value is so small, what is my conclusion on the heat?
We don't. Wait. Oh, we don't accept the null?
I don't know about accepting. I've never heard that word accepting.
Reject. Oh, wait.
If the null is low, sorry,
let it go.
if the p-value is low,
With how many times you're asking me this.
that's why I keep asking you. If the p-value is low, the null must go. Reject H naught. The data does not support H naught. It favors the alternative. It favors the alternative. Now, the chi-square graph looks something like this. It's a very right-skewed graph. So your critical region, the rejection region, where you would have to be to reject the null hypothesis is off to the far right. So big chi-squared values is when we would reject. 193.55 is pretty large in the grand scheme of things. I mean, it would be nice to know how large. It would be nice to know what the cutoff point is. What's the cutoff point? What is the critical value? What is the value for which any chi-squared past that, we reject the null hypothesis, and any chi-squared before that, we do not reject the null hypothesis. So for this, we go to a chi-squared table. And how many degrees of freedom were there in our example again?
12, right?
12. So we go to the column, we go to the row that corresponds to 12 degrees of freedom. And if we use a 5% significance test, then what would be the critical value? What will be the point at which anything beyond that, we reject the null hypothesis?
Would it be 3.074?
Where do you see 3.0? Oh, I see. No. 5%.
Would it be 21.026?
Yes, right. You go to 25% is 0.05. So that's 21.026. So the critical value, 21.026. And we got 193.55. So we are way beyond that point. So whether we use the p-value approach or the critical value approach, either way, we are going to reject the null hypothesis in favor of the alternative. And it seems that these are not independent, which means one certainly seems to have, especially with a p-value that low, you never truly accept it. But when the p-value is really that low, the likelihood of having that occurrence, if the null hypothesis is true, is astronomically tiny. So if you're ever going to accept anything, this would be the time to do it. Does that make sense for a test of independence? That's it for independence test. That's the whole thing. You have your matrix of observed values. You have your matrix of expected values. The matrix of expected values is arrived at by multiplying those two and dividing by the total. You then go right to your calculator, chi-square test. It gives you your chi-square value. It gives you your p-value. And then for the p-value, you make your conclusion. If you need to know the critical value, you can look at the table, assuming 5% significance, the right number of degrees of freedom. And if your chi-squared value is beyond that, then again, you reject the null hypothesis.
Professor, on a test, how would they test your knowledge on this?
I mean, I can imagine a question along the lines of, you perform a significance, a chi-squared test of independence, and your chi-squared value is 7.36 with 5 degrees of freedom. What is your conclusion at 5% significance? So
Okay.
So your job would be to take out your table and say, oh, 5 degrees of freedom, my critical value is this number. Oh, I'm past that, reject.
Okay, so they won't expect us to put all that stuff in the calculator,
They
right?
will not expect you to do that at all.
Okay.
In fact, I'm pretty sure, and I'll find out for sure over the next few days, but I'm pretty sure that they're not going to ask anything that would require a TI-84 calculator. Versus like a handheld, one you can get for like 86 cents at a, 99-cent store. So make that 99 cents at a 99-cent store. But I'll find out for you, within the next couple days.
Okay.
Meanwhile, the other, test is a chi-squared goodness of fit test. A chi-square goodness of fit tests. And the chi-squared goodness of fit test has similarities to the test for independence. It's a little bit different. Essentially, suppose someone comes along and tells you that data comes from a normal distribution, and you say, well, how do I know that it's normal? Does the data, how well or how good does the data fit a certain model of a certain distribution? Oh, I think it's normal. Well, how good does your data fit a normal? If your data looked like this, if I made a histogram and my data looked like this, would you say, oh yeah, that comes from a normal distribution?
No.
Does it fit the data well? Does it fit the model well?
No.
No, I mean, a normal distribution looks, will look something like this, right? It'll be high in the middle, it'll taper off to either side, right? So when you have data, the question is, how good does your data fit a certain model? And we want to test it. If you come along and say, I think it's normal, I'll say, well, I'm going to do a goodness of fit test to determine how well it fits a normal distribution. If you say, I think it's binomial, I think it's Poisson, I think it's hypergeometric, I think it's negative binomial, I think it's this, all these different types, you want to perform a goodness of fit test. Now, in this class, the only goodness of fit test that we're going to be working with is on whether or not data fits a uniform distribution. And a uniform distribution means every value should be the same. So here's an example of a goodness of fit test for a uniform distribution. Suppose we have the following data for births. We have the number of births in some county relative to the day of the week. And we have the following data. And the null hypothesis is the data comes from a uniform distribution versus the alternative, the data does not. Every goodness of fit test will be the same. The data fits a model, that's a null hypothesis. The data does not fit the model, that will be the alternative hypothesis. Every single time. It either fits it or it does not fit it. So how do we perform a goodness of fit test? Well, the first thing we want to ask is, just like we did for the other one, if it does fit the uniform, if the null hypothesis is correct, then how many do we expect to have? How many births do we expect to have every day of the week?
Would it just be the average of all the numbers added up?
Would it be what? Say again?
Would it just be the average of all the bursts divided by the number of days?
The total births divided by the number of days, right?
Yeah.
Yeah, so if there's 140, we calculate the total, it's 140. I just did it on my calculator. So if it truly was uniform, how many would I have every day of the week?
20.
20. So my expected would be 20 for all of them, if it truly was uniform. The question is, obviously it's not 20 every day of the week, but is it close enough to 20 that we don't reject the null hypothesis? Or are they far enough away from 20 that we do reject the null hypothesis? Now our chi-squared value is computed in exactly the same way. We sum up the difference between the observed and the expected, and we square it and so on. However, even though the math tells us to do the same thing, the calculator for goodness of fit test is different. So like the t-test, like the z-test, like all the ones that came before it, or like the linear regression, we're gonna go to stat, and we are gonna put in our data into list 1 and list 2. So go ahead and enter your data, please, into list 1 and list 2. Good old fashioned lists from before. And then which test do you think we're gonna use in this one?
Wait, how do we create a list?
Stat, edit.
Are we gonna use the chi-squared GOF test?
That's the one, the chi-squared goodness of fit test. But to do the chi-squared goodness of fit test, it wants 3 things: observed, expected, and the degrees of freedom. What's the observed gonna be?
L1,
List 1. What's the expected gonna be?
list 2.
List 2. And how many degrees of freedom do we have?
I think it's 6
It is 6. And why is it 6?
because you take the rows -1 times the columns -1.
Well, that's not why, because only one column. So column -1 will be 0. That's for the test of independence. For this one, we go back to what we did in the previous chapters, which was the n-1. The number of the degrees of freedom is equal to the number of data points -1. And when we calculate it, what is our chi-squared?
7.6.
7.6 with what p-value?
0.27.
0.27. And as a result, what do we conclude?
That we do not reject the null hypothesis.
We do not reject the null hypothesis. P-value is not low enough. Which means, while I don't know for certain that this data came from a uniform distribution, the data does not force me to discount the possibility. Does that make sense?
Yes.
Questions on this approach?
No.
Questions on the entire semester? Because, ladies and gentlemen, we're done. We have learned everything in this universe that I'm ever going to teach you. Unless you, of course, take like a more advanced stat course sometime. So, I will never assume. What is that? Is that a, what the freak is that?
It's like a confetti popper.
I see. Is the final on the 18th, he asks. Well, let's take a look. The final is on the 18th, 10:15 to 12:15 in the morning. Yes. I have also been hired to give 3 stat reviews, by the way, on Wednesday, on Thursday, and on Friday at various times. Those will be online to, whoever wants to join. But it's not just, no, it will be the same code. It's my class, but it's not just for us. It's basically, anyone who's taking Math 140 who wants to sit in. There's probably other ones as well, So if you can't make my times or don't want to make my times, and you want to try a different teacher, you're more than welcome to. Someone said, do I know, can I show the schedule? On Wednesday, it's 11 to 1, 11 a.m. to 1 p.m. Otherwise, it'll just be weird. So 11 to 1. On Thursday, it's 3 to 5. No, 5:30 to 7:30. Sorry, on Thursday, it's 5:30 to 7:30. And on Friday, it's 2 to 4.
What is that for again, Professor?
Reviews, they're gonna
Review.
create a sample packet probably of like review questions to go through
All right.
that I'll do. It'll basically be like a review session.
But today do we have classes? Sorry.
We have class on Thursday. Now Thursday, we're not doing anything new on Thursday. It'll be a review session. If I make it not mandatory to come, my feeling is nobody will come. So I'm gonna make it attendance is required. But at the same time, I'm not just gonna go back to page 1 and just go through the book and say, you should know this, you should know this, you should know this, and so on. I mean, if we went over it, you should know it. It's more for you to ask me questions. So if you come and you don't have any questions, I'll just sit there in silence for an hour or whatever it is. But it's your last opportunity to come to me and say, I'm not really understanding this topic. Can we go over this one more time? Can you give an example of this? Can you explain that? Can you help with this homework question? Something along those lines. And I'm more than happy to help. And that'll be Thursday. That'll be the 9th.
I'll make a list of questions to ask you.
That's great. I think it's wonderful.
Go through all the chapters and then look at what we don't understand, ask questions.
That's exactly what you should do. That's what I want. I would love for that to happen. Yeah, and that'll be our last class. And then I'll see everyone Thursday and Saturday for the final. And I am completely serious, by the way, afterwards of just going and getting something to eat. I am down with that. Finals over, we just go and just grab something because I'm starting my diet eventually. I just don't know when. Probably never.
Are you making the exam yourself?
No. This is from the department.
Okay.
Yeah, my sister actually just sent me this little meme. It's kind of funny, but it basically defines my life. I'll hold it up. You can see it. Crap, it didn't work the way I wanted to. Yeah, this is my life right here. That's my life right there. So, yeah. 3 times. So, still 3 more than I've ever done. Anyway, so that's basically it. So yeah, for today, gonna be a short day. Unless you have questions, I'm here to answer them, and I'll stay as long as you guys want for me to answer them. But I do need, after everyone who doesn't have questions who's going to go, to speak with the people who have still not taken exam number 2, because I really would like to grade it. And I need everyone who has not taken it to take it. So if you have no questions, we are done officially for today. You're free to go with no repercussions for your leaving. And if you do have questions, ask now. Can we use our notes like the midterm? Good night, Caesar. I don't think so. I think a big, I have to ask. I actually did ask. I haven't gotten it back yet. I sent out an email tonight. Caesar, I just told you. You mean on the scores, you mean? Oh, I gotta wait for them to take it. So as soon as they take it, I think last time it took me like 2 days to grade. So once they're all in, it's not gonna take much time. Yes, you'll be getting a big formula sheet, a big list of tables. You'll even be getting, I think, a list of how to use your TI-84 to do things. That's how extensive it's gonna be. I will share it with you all so that you can compare it to what you would have made, and you can see, okay, they're giving us this, they're not giving us that, I better know this, I better know that, that type of thing. I will get everything to you, but that'll be it, I think. I don't think you'll have your own notes or cheat sheet or anything like that, just what we provide. I'm sent an email to my boss. I'm finding out for sure, and I'm pretty sure that's the case. Cool, cool. Do I know the room for the final? I did know the room for the final at one point, but I can't access my portal right now. Oh wait, portal I could access. Hold on. I think I have my password for that still. Let's see. It's on portal, by the way. You should be able to access it yourself, but I'm doing it right now. I'm logging in. So let's see, the room for the final. Hope it's Live Oak since that's my only building. Oh, let's take a look. So it is Live Oak, 1127. And my other final at the same time is in Sierra Hall, 386. That's going to be interesting. But yes, you guys are in Live Oak 1127.
So are you proctoring us?
I'm proctoring one of them, and I'll probably spend most of my time in one and then kind of walk back and forth, get one of my 3 exercises done by going back and forth a couple times. But I don't know. I have an email here. Hold on, I'll tell you. I have an email here about which one I'm proctoring. Here we go. Let's take a look. Math 140 business. I'm proctoring Math 140 SCI proctor to be determined. So yes, so you will have me. I will be there. I'll be there. How exciting is that going to be? So yeah, stupid 140 SCI. Not even business majors. What losers they are, huh? Yes, I know. We're all excited. This is gonna be wonderful. Wonderful. Jeez. You need to stop recording. Oh shit, I'm recording. Oh, just JK, LOL, ROFL, LMAO. I didn't mean it. Peace. I don't know. Whatever. All right. So who's still here? Lots of people still here. Hey, it's hanging out. Just hanging out. Love it. But if you guys want to go, I can't even play Clash Royale here. I don't have Wi-Fi. My school cut off Wi-Fi from Clash Royale. Can you believe it? Apparently, so many of the students were playing it that they were not paying attention. And so the school actually, how do I? Oh, here.
The school I work at, they like made it so we can't access the crypto market using the school Wi-Fi.
Wow, really?
Yeah, literally. I was like on the school Wi-Fi and I was like trying to show one of the teachers like the graphs and none of them were opening.
That's horrible. I mean, how are you supposed to make money while you teach?
I know.
That's just the worst.
Okay, have a nice day, Professor.
Right. Have a good night.
Thank you.
All right. What else?
Have a good night, Professor.
Good night.
I hope you finish all your work on a speedly manner.
Thank you. Me too. I'm making progress. I really am. The end's in sight. I feel it.
All right. Good luck, Professor.
Thank you. Thank you. All right, Jordan, I know you still need to take it. Lorena, talk to me, girl. What happened? She's not here. Lorena. Oh, I have to type a